You know the scene. You walk up to a table and there it is, a giant glass jar absolutely packed with candy, jelly beans, you name it, and a little sign that says, "Guess how many to win." It feels like a total lottery, right? Just a game of pure chance? Well, what if I told you it's not? Today, we're gonna pull back the curtain on how to actually win these things.
Seriously, have you ever seen someone just walk up, scribble down a number, and then they actually win? It's baffling. You're left standing there thinking, wow, they must be the luckiest person on earth. But what if it wasn't luck? What if there was a way to get ridiculously close to the right answer almost every single time?
Because here's the secret. It's not magic, and it's definitely not just luck. There is a method. It's a system, really, for decoding the clues that turns what looks like a wild guess into a calculated and often spot-on answer. And that's exactly what we're going to break down today.
We're about to arm you with 3 secret weapons for your puzzle-solving toolkit. First, we'll talk about rounding. Then, we'll use something called digit sums to act as a filter. And finally, we'll get into a little real-world physics with mass conversion.
Okay, let's get right into it with our first weapon, the rounding range. The whole idea here is to stop thinking about all the possible numbers and instead to find a much, much smaller area to search in.
So, a lot of these contests will throw you a bone. They'll give you a clue. Something like, the number of beads rounds to the nearest 100. Now, that's not the answer, not even close. But what it is a boundary. It's the fence around your search area.
For our example, let's say the clue is that the number rounds to 4,300. Now your first gut reaction might be to just guess 4,300. And honestly, that's what most people do. That's the trap.
But here's the key. Any number from 4,250 all the way up to 4,349 will round to 4,300. So our real answer isn't a single number, it's a range. We've just gone from guessing one number out of infinity to knowing the answer is one of just 100 possibilities. That's a huge first step.
All right, on to our second weapon, the digit sum. If that rounding range was like casting a wide net, this next tool is like a fine-toothed comb. It's how we start filtering out almost all of those remaining wrong numbers.
So the next clue might be a little more cryptic. Something like this. The sum of the digits is 15. This is where things get really interesting. We're not just guessing anymore, we're basically becoming detectives. Let's just take a random number for a second, like 4,281. If you add up the digits, 4 plus 2 plus 8 plus 1, what do you get? 15. So this number fits our second clue. But, and this is the important part, does it fit the first one? Is it in our range? Yep. 4,281 is right between 4,250 and 4,349. We might have a contender. So the process is pretty simple, really. You just go through that list of 100 numbers from our first step and you test each one. Do its digits add up to 15? No? Get rid of it. And here's a little pro tip. Keep an eye out for other little clues, like if they say the number is even. Well, that instantly tells you the very last digit has to be a 0, 2, 4, 6, or 8, letting you eliminate even more wrong answers.
And now for our third and final weapon. This one's my favorite. I call it the reality check. This is a pro-level move that uses a little bit of math to make sure our math is actually lining up with the real physical world.
Imagine the contest gives you 2 more pieces of info. The total weight of all the beads is 1 kilogram, and a single bead weighs about 25 milligrams. Okay, first thing you should notice is we've got a mismatch, kilograms and milligrams. We can't compare those directly.
So step 1 is we have to get them into the same unit of measurement. It's almost always easiest to convert the big one into the small one, and the number you need to know is this. 1 kilogram is equal to 1 times 1 million milligrams.
Once we've done that, the math is actually super simple. You just take the total weight in milligrams, which is 1 million, and you divide it by the weight of a single bead, which is 25. 1 million divided by 25 gives us a rough estimate of 4,000 beads. Now we have a powerful anchor point for our final guess.
Okay, Mission Control, we have gathered all of our intelligence. We've got our rounding range, we've got our digit sum filter, and we've got our mass check. It's time. Let's bring all 3 weapons together and pinpoint the winning number. So let's review the evidence. Clue number 1, the rounding, tells us the answer is somewhere between 4,250 and 4,349. Clue number 2, the digit sum, means those digits have to add up to 15. And clue number 3, our mass check, gives us an estimate of around 4,000. Wait a second. Our estimate is lower than our range. Why would that be? Well, that little puzzle brings us to one final really important concept.
The answer is in something I call the inverse rule. It sounds fancy, but it's a really simple idea that explains how an item's weight affects the total number of them you can fit into a larger, fixed weight.
It's super intuitive when you think about it. If the real beads are just a tiny bit lighter than that 25 milligram estimate, then of course you're going to fit more of them into the jar, and the final count will be higher than 4,000. And if they're a bit heavier, the count will be lower. Since our rounding range is higher than our 4,000 estimate, it tells us the beads must be a little lighter than we thought.
So, which number satisfies all our conditions? Let's go back to 4,281. Is it in our range of 4,250 to 4,349? Check. Do the digits 4, 2, 8, and 1 add up to 15? Check. And is it reasonably close to our mass estimate while also making sense with that inverse rule? Absolutely. I think we just found our winning number.
So, next time you see one of those jars, remember this. You're not just taking a wild stab in the dark. You're not guessing. You're decoding. You're using clues to filter, to narrow, and to pinpoint an answer that almost everyone else can only hope to find by pure dumb luck.
And that kind of leaves us with a final thought, doesn't it? This way of thinking, this methodical approach, it doesn't just work on jars of beads. From estimating the size of a crowd to figuring out if a sale is actually a good deal, what other everyday puzzles out there do you think could be solved with just a little bit of math?